Hello everybody. Once again, I am here with you for the another bond, or where we are looking for the solid state physics, in which the bondings in the solids. Basically, we have seen the two basic bonds, and that is called to be as an your ionic bonds, and another one is to be your covalent bonds are to be there. As far as the ionic bonds are going to be concerned, we have seen in detail that it is going to be formed due to the transfer of electron from one valence orbital to the another atom of the valence orbital, and due to that the transfer of this electron, that gives basically the stability, and it is the configuration of that molecules or the atoms will be equivalent to the inert gases, and such type of the bonds which are going to be formed due to the transfer of the electron is nothing but to be called as the ionic bonds. Well, basically such type of the bonds are having the strong binding energy, and that's why which are known to be as the strongest bonds as far as the bondings in the solids are going to be concerned. The second one also, which is to be as an your covalent bond, which is going to be formed due to the sharing of electrons in the outermost shells are to be there. As far as these bonds are going to be formed, it is just type of outermost shells are having the whatever be the one electron, whatever be the deficiency is to be there of one electron in the outermost shell is going to be there, they are going to be shared with another atoms or the molecule, and that going to be form a pair, and that will is nothing but to be a bond is going to be formed, which is called to be as a covalent bond is to be there. Now this covalent bond is also the stronger one. As far as the another atoms are coming closer, they will share the strength of the bonding, and another two pairs of covalent bonds are going to form. If there is a diamond structure is going to be there, in which you have seen the sp3 hybridization is going to be formed, and that particularly the strength is going to be divided in that fashion. As far as the pair of bonding is going to be increased, in that case there in this carbon are having the four covalent bonds are to be there, because they are having the four electrons in the outermost shell, that is the part where the covalent bonds are going to be maximum. Now this another one bond which is to be little bit simple one, and which is known to be as a metallic bonds are to be there. Let's see how they are differ from this ionic and the your covalent bonds are to be there. And basically wherever the part which is to be related with the basically as an bonds are going to be there, this type of the bonds are going to be formed due to the partial sharing of electrons from the neighboring atoms. Now this is what somehow similar to the covalent bonds, but not exactly similar to the covalent bond, because this is what the sharing is to be there, but it is partial sharing of electrons are to be there as far as atoms are coming closer to each other. In this case, if you look at the case where the partial sharing, it is a little bit in detail when we are moving. As far as the atoms in the metals have the valence electron to form the common pool, that means to be as the metals are going to be no doubt the metallic bonds means to be the metals we are discussing in the valence electrons in the metals are to be there, and that whatever be the outermost shell are having the electron, valence electron we can say, and the common pool will be formed in between these particularly valence electrons are to be there, and due to that the common pool is going to be formed, and they are either the pool is going to be formed, they are having the freedom to move anywhere in that framework of the positive ions are to be there. And due to that what happens, the whatever be the bond or the common pool of the electron is known to be as a free electron cloud is to be there. Now this is how somehow the very important factor when the two atoms are coming closer, or the molecules are coming closer, and they are having the valence electron in their outermost shell, and the such type of the electron clouds, free electron clouds are going to be formed, and this acts like as a mobile glue binds are to be, likewise this is to be the acts like as an mobile glue, and due to that the all the whatever be the bonding is to be there, or the bond is going to be formed, which is due to this cloud, or due to that these are going to be attracted towards the electrostatic attraction is to be there, and the bond is going to be formed, and such type of the bond is called as your metallic bond is to be there. Again, going to be very simple case, as this is what the partial sharing is to be there, that is very much important factor is to be there. The partial sharing part is to be there in between the valence electron. When the we are looking for the two atoms are to be there and they are coming closer, no doubt the metallic valence electrons are in the outermost shells are to be there, they are we are closing to each other, coming closer to each other. They, whatever be the attraction pull, or whatever be the electrons in the outermost shells are to be there, they are forming to complete their fulfilling their part as an where the completion their octet or the somehow stable their cell, they whatever be the common pool is going to form in between them, that is to be known as a your electron cloud is to be there, free electron cloud is to be there. Now these type of the partial type of the whatever be cloud is going to be formed, free electron cloud is going to be formed, which is likely to be work as an mobile glue, and which binds the ion cores through the electrostatic attraction, and this mobile glue is going to be binded by the some sort of your ion cores are to be there, and due to the electrostatic attraction is to be there, and this bond which is going to be formed due to this electrostatic attraction, that is nothing but to be your metallic bonds, or which is called to be as a metallic bonding is to be there. It is very simple to understand as far as, and with the your simple examples when we will take into account, that will give you a very clear picture about these metallic bonds are to be there. So to understand this metallic bonding, let's take an example of the Na, that is the sodium is to be there, and to know that as far as the sodium atom is having the electronic configuration as like here it is to be given. If you look at this electronic configuration is to be there, that is 1s2 2s2 2p6 and 3s1 is to be there. Now if you look at here the case where the electronic configuration is to be there in the 3s, that is 1 is to be there, that means in this state one electron in the outermost shell is to be there. This is for the what the electronic configuration of sodium atom is to be there, where you can see there is a one electron there is to be there in the outermost shell, which is going to be there as an called to be as an free electron, or unpair one unpair electron is to be there in these 3s. Now when the another atom, now these are the two Na atoms are supposed to be coming closer to each other, then what happens exactly at this stage? Now this is one Na atom, this is one another Na atom. When they are coming closer to each other, or they approaches towards each other, in that case this one Na atom have one unpaired electron, this another Na atom have one another unpaired electron is to be there, and when they are approaches towards each other, at that stage the whatever be the valence electron in the outermost shell of both the atoms are to be there, they are going to be form a pair of bonding, and that pair of bonding is nothing but to be approaches forces of attraction in between them, and this attraction, electrostatic attraction, is going to be form a bond, and that is nothing but to be your metallic bond is to be there. Now as the two atoms are coming closer to each other, that time this is what the bonding is going to be formed, that is to be there. But if suppose it is not the part of only one or two atoms any solid is to be made up of, the number of atoms are there in whenever we can say as far as the your solid is going to be concerned. Now in this case, if suppose the another third one atom is going to be coming, now whenever the two atoms are coming, the whatever be the atoms coming closer, they are having the one electron pair bond is going to be formed. But when the three atoms are there, means they already two atoms are there, but another third one atom is coming closer to each other. Now in this case the two atoms are already there, the third one atom is coming in this case. Now what happens, as far as already there is a metallic bonding in between formed in between these two atoms are together. Now but the another third Na atom which is also having one unpaired electron in the outermost shell. Now when it is coming closer to these two, whatever the metal bond forms are to be, metallic bonds are formed, pair is to be there, coming pair to this pair, then what happens, this again will going to be formed, whatever be the bonding or the forces of attraction or the electrostatic attraction will be there. But the important thing is that each Na atom only forms one pair electron bonding is to be there. And here how it is going to be there, that this first atom will again form with the through all these three atoms are to be there, that valence electron. Now at this stage very important factor to understand is to be there for the first atom. If suppose this one is to be for the first atom, which will be 3s1, this another one is also to be 3s1. Now this one is the third, that is also having the valence electron in the 3s1 is to be there. But what happened already in the previous session or the at the beginning pairing of the bonding, that this one electron from the 3s1, this one electron from the 3s1, they are coming closer to each other, approaches to each other, and electrostatic attraction gives the bond formation, and that is nothing but to be the one pair of electron is going to be bonding is going to be formed. Now that is to be both are going to be satisfied, and the another when the electron is coming third atom is coming closer to this pair, at that stage it is also having the one valence electron in the s 3s1. Now these are going to be the sharing is to be there already, in that partial sharing is in between them, and they are having the outermost shell is with the two electrons are to be there, either the partial sharing considering. Now when the third atom is coming closer, at that stage the valence electron occupy the 3p state. Now here is the very important part, this valence electron are going to be occupying the 3p state is to be there. Now difference between the 3s and the 3p state is very small at that stage, where it is to be as an when it is going to be formed another atom is coming to be there, and that stage where it is to be the formation of bond is to be there, the stage will be either coming from the 3s to 3p. Now because only 3s is having two electrons already there, now when the next atom is coming, it will increase the one atom. Now where it will go, not in the 3s, it will not stay in the 3s, the next step will be go for the 3p. Now the 3p state is to be there, but again the condition is that each Na atom only forms one pair of electrons are to be there. Now how to it is, who can say it is not like that, the two unpaired electrons are bonds are going to form. What happens, it is distributing that one bonding, that means it is becoming to be as in half, and that's why it is to be saying that each atom cannot form two pair of bonds. I already told you that each atom cannot form a two covalent two metallic bonds are not going to form, only one bonding is to be there allowed, for the one bond is going to be formed, that is going to be allowed by each atom. Second bond is not going to be formed in each atom. So in that case what will be the our assumption in that case, that the each atom, now when the third atom is coming at this stage, it is becoming to be as in half sharing, and that is what it is called to be as an the third atom, only one atom of Na forms one half of an electron pair. मग या ठिकाणी जेव्हा एक दोन ॲटम्स आहेत त्यावेळेस त्यांच्यामध्ये एक पेअर ऑफ इलेक्ट्रॉन बॉन्डिंग झाली असं म्हणता येईल, पण जेव्हा तिसरा ॲटम येतो त्यावेळेस म्हणजे हे 3s फुलफिल झालं, 3s2 झालं, पण आता जर थर्ड इलेक्ट्रॉन म्हणजे थर्ड ॲटम आला तर एक ॲडिशन इलेक्ट्रॉन घेऊन आला, मग 3sमध्ये तर नाही थांबणार, मग पुढच्या स्टेटमध्ये जाणार म्हणजे 3pमध्ये जाणार. पण 3s आणि 3p एनर्जी लेवल्स हा डिफरन्स यांच्यामधला फार कमी आहे. ठीक आहे, थर्ड ॲटम आला त्याच्यासोबत वन इलेक्ट्रॉन पण आला, मग हा आल्यानंतर ह्याच्यामध्ये कंडिशन पुन्हा काय आहे की एक एन ॲटम दोन दोन पेअरिंग ऑफ बॉन्ड्स कधीच फॉर्म करत नाही, एकच फॉर्म करतो. मग ह्यामध्ये काय होऊ शकते, मग असं त्याचं कन्सिडरेशन करण्यात आलं की जेव्हा थर्ड ॲटम यायला आहे विथ वन इलेक्ट्रॉन व्हॅलन्स इलेक्ट्रॉन विथ इट, म्हणजे त्यासोबत एक व्हॅलन्स इलेक्ट्रॉन आहे, त्यावेळेस प्रत्येक ॲटम तर एकच बॉन्डिंग फॉर्म करणार आहे, मेटॅलिक बॉन्डिंग. पण जेव्हा अशी कंडिशन येईल त्यावेळेस काय होणार आहे, ही एकच बॉन्डिंग हाफ हाफ झाली. म्हणजे ईच ॲटम नाव कधी ज्यावेळेस तीन ॲटम्स क्लोजर आहेत त्यावेळेस काय झालं, ईच ॲटम और वन एन ॲटम फॉर्म्स वन हाफ ऑफ ॲन इलेक्ट्रॉन पेअर. म्हणजे काय म्हणलं मी, वन हाफ, एकचं काय झालं हाफ हाफ, म्हणजे दोघांमध्ये काय झालं हाफ हाफ पेअर ऑफ बॉन्डिंग. दॅट इज वॉट द पर्टिक्युलरली बॉन्डिंग. आता ही बॉन्डिंग काय लोकलाइज्ड नाही आहे, that is what to be as an firm and it is movable. In that sense, that is not the directional is to be there, it is having the movable part is also to be there, and that's why this type of the bondings are to be said not to be as an too much strongly, it is to be as an connected to each other. म्हणून ह्याच्यामध्ये डायरेक्शनॅलिटी जी काय आहे ती व्हेरिएबल राहते. म्हणून दॅट्स वाय वी कॅन से द व्हेरिएबल इलेक्ट्रॉन्स आर टू बी इलेक्ट्रॉन पेअर इज टू बी देअर. म्हणजे बॉन्डिंग जरी फॉर्म झाली कोव्हॅलंट बॉन्डिंगमध्ये जसं की स्ट्रॉंगली डायरेक्शनल बॉन्डिंग आर टू बी देअर, बट इट इज नॉट लाईक हिअर इन दिस केस ॲज फॉर ॲज द मेटॅलिक बॉन्ड्स आर गोइंग टू बी देअर. म्हणजे जसं जसं समजा कोव्हॅलंट बॉन्डमध्ये काय होते की ॲडिशनल जर समजा इलेक्ट्रॉन आला तर त्याच्यासोबत सुद्धा पार्शियल शेअरिंग करत राहतो आणि त्यामध्ये तेवढे नंबर ऑफ कोव्हॅलंट बॉन्ड्स त्याच्यामध्ये इन्क्रीज होत राहतात. पण ह्या ठिकाणी तसं नाही होत, त्या एकाच बॉन्डिंगचं त्याच्यामध्ये डिस्ट्रीब्युशन होत चाललं. it is not said to be as an another covalent another metallic bond is going to be formed. That is only the part where it is to be shared by that part is to be, and this is what the metallic bonds are going to be. मग अशा पद्धतीने एक एक इन्क्रीज झाला तर दॅट इज जसं की वन हाफ झालं, वन थर्ड होईल, वन फोर्थ होईल, लाईक वाईज दॅट. मग जसं आपण समजा इफ यू लुक ॲट द स्ट्रक्चर ऑफ द एन इज टू बी देअर, सॉरी एन ॲटम इज टू बी देअर, अँड already we have seen in the first unit crystal structure that how the Na is to be made up of BCC, having it is to be as an BCC, body center cubic is to be there. It is not exactly coming to be as an FCC part is to be there. Each atom is forms 1/8 of electron pair bonds are to be there. म्हणजे जवळपास 1/8 म्हणजे सराउंडिंग व्हॉट एव्हर नंबर ऑफ ॲटम्स आर गोइंग टू बी देअर, that much amount of the particularly division is to be there as far as one electron pair is to be there. म्हणजे एकच पेअर ऑफ बॉन्ड जो आहे तो किती सराउंडिंग ॲटम्स त्याच्या सराउंडिंग आले त्याच्यानुसार त्याचं डिस्ट्रीब्युशन झालं. मग जर समजा क्रिस्टल स्ट्रक्चर आपण बघितलं येण्याचं तर त्यानुसार काय होते की 1/8 ऑफ द इलेक्ट्रॉन पेअर इज टू बी देअर. म्हणजे एकाचेच कुठं 8 इलेक्ट्रॉनचे सराउंडिंग आहेत ते त्याला काय होतात पर्टिक्युलरली स्टॅबल करायचा प्रयत्न करतात किंवा त्यानुसार त्याचं डिस्ट्रीब्युशन होते एक इलेक्ट्रॉन बॉन्डचं मेटॅलिक बॉन्डचं इन दॅट केस. सो इन दिस केस द एन ॲटम फॉर्म्स द 1/8 ऑफ द इलेक्ट्रॉन पेअर ऑफ बॉन्ड्स आर टू बी देअर अँड सच बॉन्ड्स आर इनकम्प्लीट. मग ह्या केसमध्ये काय होते की जेव्हा मी म्हणलं की हे देज आर नॉट गोइंग टू बी स्टेबल और जस्ट लाईक ॲज अन कोव्हॅलंट बॉन्ड or direction is not going to be formed, and that's why it is not to be called to be as an incomplete bonds are to be there. That's why it is called to be as an incomplete bonds. And as far as the covalent bonds are to be there, it is as and unsaturated covalent bonds are also we can say the and particularly incomplete and unsaturated covalent bonds are also in that case. As far as the valence electrons are going to be delocalized and particularly free to move in a crystal, same case what we have discussed, these type of the valence electrons are called to be as an delocalized and also to be as an free to move in a crystal. The such type of the bonds are free to move in the crystals are to be there. These are again the less directional than the covalent bonds. As already told you that it is not to be as an one part is going to be shared. एकच बॉन्डिंग काय शेअर केलेली इतक्या जणांसोबत, त्याच्यामुळे ह्याच्यामध्ये एक फिक्स्ड डायरेक्शनॅलिटी नाही आहे, and that's why it is less directional rather than your covalent bonds are going to be there. And also the atoms have the large vibrational amplitude at the melting point. As far as the melting point is to be there at that stage, this is having the large vibrational amplitude is to be there. So these are the factors as far as the metallic bonds are to be there. And again the very important factor is to be there here, it is to be as an these bonds are to be as an basically due to this type of the thing, these are the bonds are weaker than your ionic and the covalent bonds are to be there. No doubt the binding energy is in between the 1 to 5 electron volt is to be there. That shows the weakness of this particular metallic bonds are to be there. No doubt melting point and the boiling point of the such type of the metallic bonds are weaker than your ionic bond and the covalent bonds are to be there. Again, it having the high electrical and thermal conductivity as it is going to be the weaker one. These are fast electrical and thermal conductors are to be there. It is having high ductility and the mobility is to be there. High optical reflection and the absorption coefficients are to be there. It is also having the high optical reflection and the absorption coefficient is also to be there. So these are the factors as far as the metallic bonds are going to be concerned. So this is what the very simple part as far as the metallic bonds are going to be concerned. So thank you very much for the today, as these metallic bonds are very smaller one as compared to your covalent bonds and the ionic bonds are to be there. Next part we will see tomorrow. Thank you.